This is Lab 6 of Natural Disasters class. It's called Virtual Hurricane. It makes use of a hurricane simulation program that you'll be able to use to see how hurricanes work and what paths they tend to travel. And you'll also be able to make some changes to the environment to control how the hurricane forms and where it goes. And it'll give you a good visual experience about how hurricanes work. So the worksheet is in Blackboard, and this is the start of the worksheet. And the website below, blah, 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 the same introduction, and another copy of the link. The there's also a direct link to the virtual hurricane simulator by clicking right here, and it shows the software, and it starts running itself automatically. I'll spend the next couple 3 minutes explaining what's happening and what all the symbology means on this simulation view here. What's shown here is the geography. There's a storm, always seems to be forming off the coast of Africa and traveling toward North America. And as soon as that one's gone, a new one will come around. You do have control starting and stopping and controlling the parameters. But for now, it'll just let it run. Inside, in this map, in this simulation, there's also a representation of a large high pressure system, a very large air mass, clear weather air mass, that creates a clockwise rotation, which tends to steer and control the hurricane. As large as a hurricane is, a very enormous, massive storm, large air masses and the globe are larger than hurricanes and tend to control them. You can actually move this air mass and see the effect that it has on the hurricane. I'm right-clicking on the air mass and then dragging it, and it actually does. It is strong enough and large enough to steer and control the path of a hurricane, and even bigger than a high-pressure air system, air mass, is the global circulation of the Earth, which is represented by the white arrows, the easterlies and the westerlies that you might know from some geography class. So there's even bigger controls on the movement of the hurricane. So a hurricane, big as it is still small with respect to the biggest features. The colors that are represented on this in this view are the sea surface temperatures, and the oranger or redder they are, the hotter the temperature is. So right here is winter, showing quite a bit of cold, represented by blue, intermediate, and sort of warm water still in the tropics in the winter. You are able, you do have control over which season you watch a hurricane, you simulate a hurricane by clicking on the season. You can change to spring, at which point the cool ocean is even more so. The cool ocean water is even more extensive, and the warm air or warm water is barely warm at all. And you might find it strange that spring has the coldest sea surface temperatures in the Atlantic Ocean. That's due to the fact that water needs a tremendous amount of energy to change its temperature, either gaining energy to warm it up or losing energy to cool it down. And it's all the way into spring before the cold of the winter and the relatively cold of early spring has cooled the ocean as cool as it's going to get during the whole year. We say that the sea surface temperatures have a lag time of 6 weeks or more, actually, more than 6 weeks of a lag between the 7 weeks maybe between the warmest air temperatures, the warmest weather, and when that air actually has enough of an effect to make the warmest or coldest sea surface temperatures. So that's spring. In summer, the ocean is beginning to heat up. And finally, again, showing the effect of the lag time, the highest sea surface temperatures occur in the fall. And as you know from lecture, They tend to be around early to mid-September, with a date typically stated as September 10th that represents the highest temperatures, sea surface temperatures, and also, therefore, the peak of the hurricane season. Hurricanes being very, very strongly associated with the amount of energy stored in the water, amount of energy measured by the temperature of the ocean water. So that's fall, and we can travel around the seasons. It's also possible, just to complete my discussion of this interface, to left click on the storm and grab it and drag it around and put it in any location or make it follow any path that we want to. It's still going to resist the high pressure system, but we do have considerable control over where the storm travels. And I guess, of course, meteorologists and hazards people wish that they could take a storm and move it out of the way. We're only able to do that in this simulation model as model for modeling and learning about storms. So let's look at the worksheet and see what kind of questions are asked. It says first click through the 4 seasons. We did that. The color bands show sea surface temperatures. In which season are the sea surface temperatures the highest? Well, just to refresh about using the interface and what we learned, we have spring. It's mostly yellows, oranges, lots of blues. Those are cool, relatively cool. Warmer in the summer, more oranges. Warmer yet in the fall, and beginning to cool down again as winter takes hold. And then the end of winter and into spring, the ocean finally reaches its coldest temperature. So the answer to number 1 is the fall, which is also when hurricane season occurs. So there's a close relationship. Question number 2 asks us to go to the summer time and to just watch a storm travel from the west coast of Africa and see where it goes, and then describe the path it takes with respect to geographic locations. So it wants, I'm going to check, it wants us to do summer. So we'll go back and change the season to summer, reset, and allow the storm to travel. And what you'll see is it does travel from east to west. Storms that form in the eastern Atlantic travel toward the western Atlantic, and typically and commonly and on the average, the storm goes across, passes over Hispaniola, passes over Cuba, Puerto Rico, and the other Caribbean islands, enters the Gulf of Mexico, and it begins to drift a little bit northward, at which point the westerlies, the global westerlies, grab hold of the storm and start moving it back this way. So and it'll proceed into the North Atlantic, where it'll fade away or just provide gloomy but not disaster-like weather for Northern Europe. So I'll reset that, and you can look again. Travels from the coast of Africa through the mid-Atlantic, the Central Atlantic Ocean, skirts the top of South America, passes over Hispaniola, Cuba, and the other Caribbean islands, enters the Gulf of Mexico. And another question coming up, we'll ask you to note what happens to this storm when it hits the Gulf Coast of the U.S. And you can see what happens after it hits. It rapidly degrades from a Category 2 on the Saffir-Simpson scale to a 1 to a low pressure system, which is just a run-of-the-mill weather storm, and away it goes. So going over land seems to make quite a difference. So what you can do is, as you watch this again, you can name the path. You can describe the path that the storm takes, that by default, based on average conditions and average pathways. Next question is, when does the storm become a hurricane? Well, we can reset, and we can sort of watch the sea surface temperatures. In class, I suggested that about 80 is the absolute dead minimum for a hurricane to form. In this simulation, it looks like it's either 86 or 87 degrees when the storm actually forms. And I think that this is a slightly conservative modeling exercise that the author of this has done. But we're just reporting the facts here, and it suggests that about 86 degrees is the break point. Let's see here. C asks for what happens when landfall is made on the Gulf Coast, and you saw that the storm degrades. Again, part two, question two is just descriptive, not explaining anything yet. Question number three, it says we're observing a excuse me. Number three says we're observing a storm moving through the Atlantic, the tropical part of the Atlantic Ocean, and we can do each season. And then it asks for a comparison between the paths that storms, hurricanes seem to take in spring and winter compared with the paths that they seem to take in summer and fall. And summer and fall are basically cover the entire hurricane season, and the paths and behavior are different than in winter and spring, going chronologically, where other paths are followed. So let's just take a quick look at each of those. We can go with winter-spring, reset, and watch the path. And here the pressure system, high pressure system, is differently located. The global circulation is somewhat different, and the storm forms, but then does not approach North America. And that's true. We never find a hurricane or tropical storm after December. After December in North America. Only unlike moderate storms in the very equatorial areas here. So winter and spring, the same pattern holds, as you'll see. And the colder sea surface temperatures, unlikely to get a hurricane at all in the spring, let alone a hurricane that approaches the U.S. Summer, however, is different. And summer, the circulation, the overall circulation is a little different, and you follow the arrows, and summer storms do tend to form earlier, get larger, and they do tend to impact the North American continent. In this case, traveling through the Gulf of Mexico and reaching the Gulf Coast. And by summer, generally, we're talking about the later summer, like August. And finally, the fall season, which resembles the summer season. Once again, the prevailing winds are persuading the storm to travel through the Caribbean or getting to the Caribbean, perhaps to best effect for the storm being the biggest, avoiding land by going through this strait right here and entering the Gulf of Mexico. So that's question number 3A. Describe the paths in winter and spring, and describe paths in summer and fall. And these two seasons have a very similar behavior of storms, and these two have a very similar and different behavior of storms. It says, during which season does the storm develop into a hurricane? That's another observation rather than an explanation. So we'll go to spring, reset, and let the thing run, and see if we actually get a hurricane forming by default in the spring, which I don't think we do, because the sea surface temperatures just are not getting up to a solidly into the 80 degrees. Other three seasons, yes, a hurricane does tend to form. Just to show you that it's probably not the spring season. During which season does the strongest hurricane develop? That would be the fall season, as you clearly saw. And the explanation that applies for several different questions in this exercise alone, and is a very common answer to questions about hurricanes, is that the strongest hurricanes develop when the sea surface temperature is the highest, because at that time there's the largest amount of energy available in the ocean waters to support the hurricane development. Question D, how is the strength of hurricane related to sea surface temperatures? That's just a slightly more general answer to what you put down for part C. Now we're going to consider, for the last few questions, the fall seasons. And only fall, which is the high sea surface temperatures and the most hurricane activity. And now you'll go ahead and actually move the storm yourself in some cases to answer the rest of the simulation questions. So it says here, move the storm slowly westward, passes directly over one of the large islands. Why do you think this happens? So what it's asking is, go to fall and restart the storms, and just watch them go and drag it through. We can speed it up a little bit, and I'm going to divert the storm a little bit so that it passes right over the large islands of Hispaniola and Cuba. I missed Cuba a little bit in that case. I'll just back the storm right up because I can left click and move it through. When it hits Cuba, the storm degrades substantially, and if I really steered it to an extreme right over the islands, spending all that time that I'm now forcing it to do traveling over land causes the storm to degrade and fall apart, and only when it gets over warm water again is it possible for the storm to become a hurricane again. But it doesn't have enough time to become a major hurricane again. So that's basically the answer to moving over an island. And moving over an island is, again, the same answer. Less available heat energy. There's much less heat in a land mass than there is in ocean water. So there's much less stored energy in land, and also much less moisture available. So less moisture, less energy to feed the storm causes it to degrade and to break down when it passes over land masses, including these large islands. We're also going to, number 5 is asking us to steer the hurricane across Florida. Progresses up the coast. Nope, that's number 6. 5, we're going to let the storm move up along the east coast. Number 6, we're going to move the storm across Florida. And I'm going to do both of those in a single visit to the simulator. I'm going to reset, and I'm going to push the storm over here. And it's going to, I believe, up too close to Florida. I'm going to move the storm out here, hold it for a second and let it develop into a strong hurricane. Nope, still wants to go inland. We'll try again. I've had good luck so far with controlling these storms. So we're going to let the storm follow the... Oh, messed that one up. And I don't want to start over this whole video and do the whole 15 minutes again. So we're in the fall. We're going to watch the hurricane and allow it to travel up along the east coast of the U.S. without reaching land is the trick here. So it's going to travel up the east coast, and it's still not on land, and it's actually caught a wind vector. It's starting to drag it northward, and it did go on land. Very bad luck. What we're expecting this now, that'll certainly force it to travel along the now we've got a major hurricane traveling northward off the coast of North America, a little further than I wanted, but it's not crossing over land. However, you notice that it is reducing in intensity, and it's degrading, again, fairly rapidly. The reason being that even though it hasn't crossed onto land and has stayed over water, as the storm has moved northward, it's encountering much colder water as it goes, and the colder water provides less energy and the storm degrades. There's also the possibility of grabbing the storm and forcing it to move across Florida, and it's a major hurricane passing over the peninsula. It falls apart all the way down to a 1, and when it gets back into the open Gulf of Mexico, usually where the warmest water is, it rebuilds to a major storm again. So crossing over land, crossing to cooler water, all things that are fatal to a hurricane. And that was number 6. Number 7, I'm going to test my luck and test my skill to see if I can create a Category 5 hurricane. I suggest that only in the fall season is it possible in real life and in this simulation to have a Category 5 hurricane occur. So I will manipulate the path of the hurricane, and I will set it to the fall and see if I can create a Category 5. I'm 2 for 3 today in practice, and let's see how it will go. So what I want to do, and the strategy, when you try to do this, if you can create it, you'll report both your strategy, you'll report your success and your strategy. My strategy is to keep it over the very warmest water while slowing it down a little bit, by making it backtrack, and avoiding land masses. So I have a 3, which is a good start. Hit some land, entering the Gulf of Mexico, and I'm going to slow it down and intentionally slow down the progress of the storm. I've gotten to a 4, and let it move very slowly over the warmest available water, and that will help it become a 5. Any moment, and I'm now in 3 for 4. So that would be, and notice rapidly it breaks down. So it just like any other storm that moves over land and loses its source of energy, it breaks down. And that's the complete lab. And use this video to your heart's content.